In this video, we're going to be looking at how to approximate numbers with operations, and looking at this particular example here. This here gives us two ropes or pipes. One here is measured to be 17.5 meters, and while the other one is 0.845 meters. And the question here is, what is the total length? Now, looking at these numbers here, they are not exact, they are approximate numbers. So, what are the ways by which we can actually get really close to the actual value? This all comes down to the last significant digit and how we can look at the small version and a larger version, and also looking at just these actual numbers that are shown right here. So looking at the actual numbers, when we add them together, this is what we have as a result, where we have 17.5 meters. We're going to be adding 0.845 meters. So as a result of these, our meters is going to be there, and we have 5 brought down, and this here for 100 we have our 4 to be brought down, but here we have our tenth, which are the numbers we're going to add together. 5 plus 8 in this case, that gives us 13. So we put our 3 down and we put our decimal point, and that 1 we're going to add it to 7, that gives us 8, and then we have our 1 brought down here. So this here is based on the actual numbers that are shown right here. However, when it comes to the smaller version, or the smallest possible value for the addition, we're going to look at first for 17.5, we're going to use 17.45 here as the smallest version, and this here in terms of meters. On the other side here we have our 0.845 meters. We're going to use the smallest version of these to be 0.8445, and so these here are the numbers that we're going to be adding together, and this here is going to give us the following. And finally here is, we're going to be looking at the largest possible value that is going to be gotten from these two numbers, and in here we have our 17.5, which in this case will be now 17.55, and this here in meters, and for this number here it will be 0.8455. So this here is the largest version or possible value for this not exact numbers that are here. Therefore, adding them together, we have, so this here is the smallest possible value for the sum of this. This here is the largest possible value for the sum of this. Now, in terms of the addition of these two numbers here, we are going to be getting our rounded off to the nearest tenth, because so addition of approximate numbers involves looking at your final answer to be rounded to the nearest smallest precise number in the addition process. And so in this case here it is 17.5, and 5 here is the 10th. Therefore our value here won't be, in this case, 18.345. it will be, instead it will be 18.3 meters in terms of rounding off to the nearest what, 10th. And so we're going to look at other rules for subtraction, multiplication, and division for this particular video. Now, therefore, looking at the rules, the first rule here looks at showing the result from the least precise number. This applies to the operations, which are, of course, we talked about addition, but also applies to subtraction for this particular rule. And so the next rule here, which is the second one, says that to show the result, what we have to do is we determine it from the least accurate number, and this here applies to multiplication and division of those two numbers or more numbers, and this here is what we are focusing on for the second law. Now, the third rule in terms of determining the result here says that to show the result, you have to look at the accuracy of the given number. So that means that you must apply an operation known as the root of that given number. And so whenever you do that, if your answer is in decimal, usually of course there are irrational numbers, that means that your answer should be based on what is given in terms of the accuracy, which means the number of significant digits that are present in that number. And finally here, which is going from our third law to now the fourth rule here, says that you need to show the result from the accuracy of the approximate number only when you're having an approximate number applied to or with that of the exact number. So example would be given a whole number which doesn't have a decimal digits after the decimal point versus numbers that have more, or that is more precise, then that is where our approximate number in terms of more significant digits matters because of the term accuracy shown here. So now in here we got an example that says that we are going to first multiply our negative 13.8 by negative 4.67, and then our result we're going to apply it to our 48.4. So first step doing the modification, make sure that you show all the digits, significant digits, and also all digits for your answer. And in this case here we have our value to be positive 64.446. However, if you're doing this operation only and you're getting this as your final answer, that means we're going to look at the accuracy of our numbers that we multiplied. The least accurate number is what we're going to use, which means that the number that has the less significant digits is the ones that we're going for. But in this case, all the digits here, 13.8 and 4.67, they have equal significant digits, in this case 3. Therefore our value here will be 64.4. But here we're not going to do that. We're going to keep this and we're going to apply it by adding it to 48.4. And what does that give us? This here gives us 112.846, and this here is the actual number that is going by keeping all the digits after you perform the addition. Now to get the result in terms of the rounding, in here our value is going to be based on the precision, and precision here means that how many significant digits are after the decimal place here, which one is the least number of digits that is after the decimal place. And in this case here it is going to be 48.4 compared to 64.446, where 6 is placed at the thousandth. However, 4 is placed here as the 10th. Therefore our answer for this is going to be approximately 112.8 as our final answer. Now the next example shows us the following, where we have an approximate number, in this case 3.6, and we're going to apply operations, in this case addition, subtraction, division, multiplication, to an exact number, which in this case here is 500. Therefore in this part here for addition, remember here that because 500 is an exact value, our number here is going to be the determining factor here in terms of the result, without using the calculator, to be equal to 503.6. This here, when we use the rounded value, we're going to use this as our final answer. Likewise for the subtraction here, which will give us in this case 496.4, and this here is going to be dependent on the accuracy from the approximate number here, 3.6. Now, in terms of multiplication and division, the same rule applies. However, we express this based on the accuracy, which means here that we're going to be looking at two significant digits as our answer, and this here is equal to 1800, and that is for the multiplication. And for division here, in this case 500 divided by 3.6, when you hit your answer, it gives you around this number 138.888. It repeats, and so this here we're going to leave it to the two significant digits, and this here means that our value will be approximately equal to 140 as our answer for this result here, because we are dealing with the accuracy here for this result. However, for the additional subtraction part, we're putting our value to the nearest tenth, which is looking more on the precision of our approximate value. So overall, I hope you found this really informative in terms of being able to address the following laws to the following question with regards to approximate numbers with operations like multiplication, addition, subtraction, division, and how this here can enable you to get the proper value depending on what is given to you in a question. All the same, thanks for following me through this. Truly appreciate it. See you on the next one. Stay smart as always and believe in yourselves.